Have you ever thought that a simple, run-of-the-mill sore throat could actually lead to serious, lifelong heart damage? It sounds crazy, but that's exactly what we're talking about today. This is the wild story of rheumatic fever. So here's the central mystery we're going to unravel. How does a super common bacteria cause such a profound case of mistaken identity that our own immune system, our body's personal security force, gets tricked into attacking one of our most vital organs? Let's dive in.
All right, every good mystery starts with a trigger. To really get what rheumatic fever is, we have to go back to the beginning and meet the initial culprit that kicks this whole dangerous chain of events into gear.
And here it is, Streptococcus pyogenes. You've almost certainly heard of it as Group A strep. This is the bug that causes strep throat. We're not talking about some rare exotic virus here. This is an incredibly common bacteria, one that tons of us have encountered.
But here's the first major plot twist. Rheumatic fever doesn't pop up while you have strep throat. Nope, it shows up 2 to 6 weeks later. Now, this is a massive clue, right? It tells us that the real damage isn't being done by the bacteria itself. It's caused by our body's delayed and very confused reaction to it.
And while, anyone can technically get this, just look at these numbers. A whopping 70% of cases happen in kids and teenagers between 6 and 15 years old. So this is a disease that, more often than not, really targets the young.
So how on earth does this happen? How does a past infection come back to haunt the body? Well, the answer is a fascinating and, frankly, dangerous biological mix-up called molecular mimicry.
Okay, let's walk through this step by step. First, the strep bacteria gets in. Easy enough. Your immune system, doing its job, creates these specialized soldiers, antibodies, to go after a specific part of the bacteria called the M protein. Think of the M protein as the enemy's uniform. But here is where it all goes wrong. Those same antibodies, now on patrol, bump into your own healthy cells in your heart, your joints, your skin, and they mistake them for the enemy. It's a devastating case of friendly fire. Your body's own defenses are now attacking you.
And this whole situation has a name: molecular mimicry. It's exactly what it sounds like. The protein on the bacteria is mimicking. It looks incredibly similar to proteins that are naturally part of your own body. Your immune system, trying to do the right thing, gets totally fooled by this lookalike and can't tell the difference between the bad guy and you.
And here you can see the problem side by side. On the left, you've got that bacterial M protein. On the right, a totally normal protein in your heart muscle called myosin. To those antibodies your body made, they look like twins. So the antibody that was designed to take out strep throat accidentally latches onto your heart muscle and starts attacking it. The most important thing to get here is this is not an infection of the heart. It is an autoimmune attack on the heart. Your body is fighting itself.
So, if it's such a complicated process, how do doctors even figure it out? Well, this is where the detective work begins. Diagnosing rheumatic fever is all about piecing together clues from the recent past and the present.
Rule number 1 for the detectives, the doctors, is you have to establish a link to the original crime. You need proof that there was a recent Group A strep infection. Sometimes it's a positive throat swab, but often, since the strep is long gone, it's a blood test that shows the antibodies against strep are still floating around.
Okay, once they confirmed strep was on the scene, doctors use this special diagnostic checklist. It's called the Jones criteria. And it's pretty simple, actually. To make the diagnosis, they need to find either 2 major clues or 1 major clue plus 2 minor ones.
So the major criteria you see on the left, those are the big flashing red lights. Things like carditis, inflammation of the heart, or this really strange one, Sydenham's chorea, which causes these jerky, involuntary movements. The minor criteria are more general signs of being sick, like a fever or just having sore joints. The doctor's job is just to see which boxes get checked.
But of all the things on that checklist, this is the one that really worries doctors the most: carditis, inflammation of the heart. And why is that? Because the arthritis will go away, the rash will fade, but the damage done to the heart valves during this attack can be permanent. It can lead to a lifetime of problems.
So this brings us to the response. Once the diagnosis is confirmed, the game plan is clear. Stop the friendly fire and manage the damage. It's all about telling the body's overactive defense system to stand down.
The treatment strategy really has 3 main parts. First, you have to target the trigger. You use antibiotics like penicillin to make absolutely sure there's no lingering strep bacteria still poking the immune system. Second, you reduce the inflammation.
You use anti-inflammatories like aspirin to calm everything down. And finally, you just have to manage whatever specific complications have already popped up.
But here's the thing. Treating that first episode is really just the beginning of the story. The real long-term challenge is what happens next. It's all about protecting the heart from any future attacks.
And this is why that protection is so vital. The biggest danger, the ultimate fear with rheumatic fever is rheumatic heart disease. This is the permanent scarring and damage to the heart valves that got caught in the crossfire. That damage can make it harder for the heart to do its job for the rest of a person's life.
When you lay it all out like this, the whole story becomes crystal clear. It starts with strep throat, which is just a simple, treatable infection. If you treat it, you can prevent the immune system from overreacting, which means you prevent rheumatic fever, a preventable reaction. And if you prevent that, you prevent the permanent damage of rheumatic heart disease, a chronic condition. The takeaway here is so powerful. Treating a sore throat can literally save a heart.
And this all brings us to the future. You know, right now, scientists are working hard on creating vaccines for Group A strep. So the final question to leave you with is this. If we could stop that initial infection from ever happening in the first place, could we one day make this entire devastating chain reaction, this whole case of mistaken identity, a thing of the past?